Okay, one thing that we need to talk about before we do any real life problems is what is the use of circumference? Like, what kind of questions are they going to ask you? And the number one type of question that they're going to ask you for circumference is revolutions, like a Ferris wheel spinning or a car tire spinning, something like that, a bicycle wheel spinning, something like that. Okay, so every time that you have a wheel, it doesn't matter what type of wheel it is, every time that it makes a complete revolution, meaning that it comes right back up to where it started, that's circumference. So if it tells you that it makes one full revolution, one revolution is also equal to the circumference. And that's always true. Okay? So if they said something like, it's spun 3 times, then you would have 3 circumferences. So just keep that in mind. Another thing that you have to think about is, like, different shapes might have circles in them. Like, let's say that you had a square, and then you had a half circle on the top, and they wanted you to find the circumference. What you have to do is you have to find the perimeter, from here to here, from here to here, here to here, and then around the circular shape as well. And you do that just like you normally would. So let's just give us some numbers here. Let's say that this was let's just make it easy on ourselves, and let's say that it was a square, okay? And let's say that it's 10 inches something, okay? And so that means that this is 10, and this is 10, and this is 10, and so is this 10. Well, so far we have 30, okay? So 30 here so far. But we don't know how far this really is. So that's where we are right now, trying to figure out how far this is. And that's where circumference comes in, because if it's truly a half circle, then what we have, let's draw it here, we have a half circle with a diameter of 10 inches. And what we do is we take the circumference. If the diameter is 10, which it is, because think about it, if it was a full circle, then the diameter will be 10. Now, it's not a full circle, it's a half circle, but still, same concept. It'd be 10 pi, right? But it's only half of one, so we're going to take half of it. And that would be inches. So, of course, it's going to be 5 pi inches. And then we would add that to the 10, or the 30, let's put it that way, after we converted 5 pi into real numbers. So it would be 5 pi, convert that to real numbers. It'd be about 16 plus 30, so it would be approximately 46 inches around this shape. And I don't have a calculator with me right now, or I would give you exact, but still the concept is there. So whenever you have a half circle like this, you have to take the base of it as your diameter, and then you have to find it as if it were a whole circle, and then take half of it because it's half a circle. And another thing that you might need to know is if they give you circumference. So let's say that they give you circumference is 50.24 centimeters. And maybe they want to know what the radius is. Okay? How would you figure that out? That's really the question here, because there's no pi. We can't just yank diameter out of it, because, like, normally it would look like this. It would be like maybe 10 pi, okay? And then we would know that this is the diameter. But they've already converted it to decimals. So it's some number times pi. We know that. But we don't know what that number is. So the very first thing that we have to do is take 50.24 and divide it by pi. And in this worksheet, I think they're going to have you use 3.14. So we're going to divide it by 3.14. And I'm going to go ahead and take this out and just make sure we realize that we're dividing by, we're saying it was being multiplied by 3.14, even though it is pi, but we're using a rounded version, okay? And if you take 50.24 and divide it by 3.14, you get 16. So that means the diameter had to be 16 centimeters. But they didn't ask you for the diameter, they asked you for the radius. So now, what you have to do is you have to take the diameter, and then you have to take half of it, because the diameter is all the way across the circle, and the radius is only halfway across the circle. So there will be some questions that will make you have multiple steps. Alright, so I'm going to work some out with you. I'm going to work number 9 out, number 11, number 16, and then I'll see how it goes. So let's work out number 9 first. So try it by yourself first. Read it. We're going to find the perimeter, and it says all curves that are shown are semicircles, which means half circles. So think in your head what you would do first, before I do it, and see if you would have gotten it right. Okay, I drew it, but I've done a horrible job, but it's okay. So remember that we are only trying to find the outside edge. These two lines right here, we know exactly what they are. They're 50. So far we know it's 100. I'm going to write that down. So far, the perimeter is 100 yards. Okay? We definitely know those two. What we don't know are these curves right here. Okay? And that's what we're trying to figure out. We don't care about the inside. Circumference, perimeter, they don't care what's happening on the inside of the shape. They only care about the outside edge. So when we look at the shape, trying to figure out, what this outside curve, how much distance it is all the way around it, we actually do need to know this distance. Because just like we did with the half circle like this, we need to pretend like it's a whole circle and use this as our diameter. And so we need to know that, and they do tell us that it's 60 yards. So I'm going to take this and I'm going to say this is 60 yards. Alright, so come here, and this is 60 yards. And it's not really a whole circle, but we're going to pretend like it is right now. So if it were a whole circle, the circumference would be the diameter times pi. And the diameter is 60 pi yards. But it's not a whole circle, right? It's only a half a circle. So we're going to take that and divide it by 2. So we're really going to get that it's 30 pi yards. So we do know how much it is. Okay? So the green part, if you want to call it that, is 30 pi yards. And so is this one over here, the same thing. But we actually need to know how much 30 pi is, so we need to put that in our calculator. So let's read the instructions, and let's make sure we're not supposed to use 3.14. And we are. It says use 3.14 for pi. So we're going to use 3.14. Make sure you're not using the pi button, because if you are, you won't be able to find your answers on the left-hand side. So when I put that in my calculator, I get that 30 pi is 94.2. So this is 94.2. So now it's not only 100 yards, it is 94.2 plus 94.2 plus 100. Okay, so whatever that is, that's going to be the distance around that shape. So it's 288.4 yards. And let's look and see if we can find it on the sheet. Oh, I see it right there. And we're supposed to cross out the letter right beside it. So number 9 is done. So take that in, make sure you really understand that we did not care about anything inside, perimeter, circumference. It's only about the outside. All right, number 11, think in your head about what you would do before I do it. How would you solve this? All right, looking at number 11, hopefully you'll be able, I know you can see the shape. If it were a whole shape, it would be a rectangle that's 7.5 by 9.2 meters. But it looks like something has taken a bite out of it. So what we have to do is we have to find kind of the perimeter for 3 sides, and then the perimeter of the bite, pretty much. So we're going to take 9.2, 7.5, 7.5, and then we're going to have to find the circumference of the curve to find out how much that's going to be, and then add it to the other 3 numbers. And that'll tell us what the actual distance around this shape is. Because don't forget, perimeter is just distance around the shape. So 9.2 here, 7.5, 7.5, and then we don't know. That's what we're trying to figure out. So let's go ahead and draw the semicircle. Okay, so here it is, and what we need to know is what the diameter is, because we have to pretend like it's a full circle. So once we know what the diameter is, we'll be able to find the circumference, and then we can take half of it, because we know it's not a full circle, it's only half a circle. So we look back on the shape, and whatever it is up here, it's the same thing down here, and so it has to be 9.2. So the diameter of this circle, which I know it doesn't look like a circle, but would be 9.2. And the circumference would be 9.2 pi meters. But again, we know it's not really a whole circle, it's only a half circle, so we have to take it and divide it by 2. And then even more than that, we know that they told us to use 3.14 instead of pi, so we have to take 9.2, divide it by 2, and then multiply it by 3.14. And when you do that, you get that the circumference is 14.44444. But we're going to round it because I know that they're rounding their answer. So we're just going to leave it at 14.4 meters. And so let's go back to the drawing. And we're going to write this in. So 14.4 here, if I could write. And then we have 7.5 over here. So we have our 4 numbers. So what we would just really need to do is just add up all 4 of those numbers, because we are talking about the outside edge here. All 4 of those numbers would give us the distance around that shape. And then whatever that is, that'll be the answer that we're looking for. And I get 38.6 meters. And I have to scroll down, and there it is. Goodness gracious. So you need to cross out the P beside it. Okay, so number 16 says the first Ferris wheel, designed by George Ferris, was built in 1893 in Paris, France. It had a diameter of 76 meters. About how far would you travel in 8 turns of this wheel? So imagine if the Ferris wheel got detached and you actually moved every time that it turned. How far away from where you started would you end up if you actually went, if it did 8 turns before it stopped? Think about it like that. Like, would you go 800 feet? Would you, well, they're talking about meters. So we're going to see how far away from our destination, or our origin, really, would we actually end up if the Ferris wheel detached from its structure and we ended up rolling down a hill or something. So the important information that we need is the diameter. It tells us, well, it told us the diameter, 76 meters. Okay? And the circumference is diameter times pi, QD pi. And so that's 76 pi. But don't forget that they want us to use 3.14. And that's fine. And that's meters too. But more than that, they said, what if you actually spun 8 times? So we're going to take the circumference, however distance this is, and then we're going to multiply it by 8, and that'll tell us how far we really would have traveled if we had rolled down a hill 8 times in the Ferris wheel. So if you take that and put that in your calculator, you get 1909.12 meters. So I'm not really good with meters, but I know that that's, if you turn that to feet, it would be times 3. And there's about 5,000, more than 5,000 feet in a mile. So I know that's a little over a mile. So that's a long way. So let's see if we can find our answer on the sheet. And it is right here. So cross out the A. Okay, I just Googled it, and it's about 1.2 miles. So, just so you know. Alright, I do want you to finish that page. Some of them can be a little tricky, so make sure that you're using your notes and that you think for yourself. And if you have any questions, that you ask for help.